your textbook. So chapter 3 is actually where we kind of get into more calculations now, because we haven't done that many calculations at this point. So chapter 3 is where, we get into measures of central tendency. So that's where, we talk about averages. So we get into mean, median, mode, weighted mean, and all of those calculations. We get into measures of dispersion or measures of variation. That's where, we talk about range, variance, standard deviation, those calculations. And then we also talk about measures of position. So, this is where we discuss your quartiles, percentiles, z-scores and those kind of things. And then a little bit of discussion with distribution. So you will see just a very brief introduction to what we call as empirical rule. We will build up on that later on as the normal distribution. So this will be more of an intro kind of thing. And we also talk about Chebyshev's theorem or formula, depending on what your textbook calls it. Lola and Amaya, I'm not able to see you guys. Can you make sure that I can see your faces, if you don't mind? Amaya, all I'm seeing is what looks like a ceiling. It needs to be focused on you. So if you wouldn't mind readjusting your camera, please. As always, you will see, I'm trying to see if I can get into your D2L course shell just to kind of, again, quickly show you what I'm looking at. Give me just a quick second here and I'll turn this. Okay, so if you look into the week 3 assignments, from this week, you will see that is where we're focusing on our, measures of central tendency, like I said, standard deviation, and all of those different calculations. So as always, you will have your reading assignments, your viewing assignments. Again, before you dive into your activities or, anything, just make sure you understand the concept behind it. You understand what you are, getting into, what this chapter involves before you start tackling your activities and assignments. So what I have us for here today is just to kind of, again, get you started on, just some basic calculations. So let me share, again, I have this Google Sheets document over here. And I'm going to send you the link through our chat here in Zoom. So right here in Zoom, you should see your link coming through. All right, I can see you guys getting on there. All right, so this was just a kind of another one of those fun databases. As you can see, this one actually talks about Christmas songs and just kind of what kind of rating they had, on the Billboard charts. So it kind of shows you, the week position, during which week was this, maybe on the Billboard charts kind of thing. So you will see there are different columns over here. There's the week ID, which I think is so long that we're not able to look at it, but basically it shows you the different dates, when that song was on the chart. You've got your week position. So it basically tells you at what number the song was, during the charts, when it was on the charts. You can see its position previous week, if they had that data, if it fell down or went up the charts, the peak position, so the highest rating it had, how many weeks the song stayed on the chart, and those kind of things. And then here's your date, the year, month, and day of when the song was on the Billboard charts. So again, just something different than what we would normally see, like in a textbook example kind of thing. So if you go over to sheet 2, you will see I've kind of created just a basic table where you guys will need to put your information in. So we need to basically figure out what the mean, median, mode, range, and standard deviation for this data set is going to be. But we want to do it a little bit differently um, than have you do like the whole entire database. So what I would recommend you guys to do is, the best way to do would be to go under file over here and make a copy of this database. So that way then you can kind of edit it, rearrange it however you want to. If you want to do this by a particular song, so if you have like a favorite Christmas song, if you listen to, you can do it that way. You can do it by performer, so maybe see if the same performer has different songs on the charts that came through, or however you want to break this down. But I want you to sort it as per your preference, and then you can use the weak position to kind of see, did the same song have different ratings. So kind of just to show you, let's say if I do this by song, and we'll go ahead and sort this out. So I'm going to sort this by A to Z. So hopefully you can see that happen as you look at this document. And so you can see how we have, let's focus on this one for Mariah Carey, the All I Want for Christmas over here. So you can see how this song has been on the Billboard charts for a long time. Oh, okay, Jacob, you didn't get the link to work. Okay, you should see that link come through. So, okay, like I said, if you wanted to focus, you can see in the middle, they kind of have this another singer in here, Michael Bublé. So if you want to, not use that singer and just focus on the songs by, let's say, like I said, Mariah Carey, then you can look at the different, you know, weak positions that we have over here for this singer. And then you can kind of do calculations based on that. If you keep going down, you will see others. So we've got, looks like by Goo Goo Dolls, I don't know, Band-Aid, all kinds of different performers and what songs they had. So pick what songs you would like to work on, what artists you would like to work on. You can sort your list as you want. Like I said, make a copy before you do that, because since this is my master copy, I don't want to mess around with this document too much. So just make a copy of this for yourselves, but then you will need to come back to this original document to put in your information here on the second sheet that I have for you guys to enter information. So I want you to play around a little bit. I've given you some hints in terms of how you can do these calculations. I've given you the functions that are built into Google Sheets or even Excel. If you wanted to do this in Excel, then you can download this on your laptop and do it that way. But you have the average, median, mode, the standard deviation functions that are built in. And then, of course, for the range, like you did last week, to calculate the range, you take the highest data value and subtract, the lowest data value from it. And that gives you the range of your functions. So basically, that's kind of what you guys are doing over here. So I'm actually going to put this back in its original form. And like I said, make a copy and either pick an artist or a song that you like, and then go from there. Look at that weak position numbers, the numerical values, because that's what we need for our calculations. And then you can, do your calculations based on those numbers. So go ahead, make your copy, and then, see how it goes. If you get stuck on something, I am here to help you out. Feel free to help each other out. Also, you can talk to each other and look for help. And I will check in with you guys in about 5 minutes time, okay? Oh, okay, Crystal, are you able to hear me now better or still having trouble?
Now I'm fine. It was like in and out that I was hearing.
Okay, so what I was saying is, and let me send you that link again, just in case you didn't receive it before. So this will take you to the database for the Christmas songs, kind of on the Billboard charts where they were, when they were, I guess, at the top. So what you are doing is you are sorting your list based on either the songs or the artist. And then you can pick your favorite artist or your favorite song, whatever you like, or even if you don't have a favorite, if you are like, okay, this is the song I like, I just want to go with that. But then you will see as you sort the list, the week position, which is like the third column, everything gets sorted, right? So once you pick your song or artist, then look at all those numbers for the week's position and use those numbers to do your calculation. So those will be, your data set, because again, it's like a 300 something long list of songs. So it's a really long list to try and do the whole list at the same time. So that's why you are just picking your favorite artist or favorite song and just using those numbers to calculate your average. So you are doing all the three different calculations that we normally look at, which is your mean, median, and mode. And if you actually click on sheet 2, you will see I have listed the different Google Sheets or Excel functions that you can use to help you out with that. So basically right now you're just picking which numbers you want to work with. So which song or which artist you want to go with. And then based on that, start doing your calculations.
I thank you.
Okay, no problem. So what about the rest of you? How are you guys moving forward? Okay, so Riley, once you have selected your, data set, so let's say you may have 20 different numbers in there, or, how many ever you ended up with, then for the average function, you will, of course, remember how you do equal to when you are using a function in Excel. So you will have to start with the equal to, type the word average, and then remember in parentheses is where you will need to put all your cell numbers. So let me show you. And right now, I'm just going to pick the first 20 numbers from our list over here. So let's say these are the first 20 numbers I'm going to pick up. If you guys are in the original link that I sent you, you will be able to see me select the first 20 numbers. And then I'm actually just going to move over to sheet 2 and paste it over here. So that way I'm not messing up with my original, list. So let's say I'll just put it on the bottom here. So if I want to calculate the mean, for the mean, I am using the average function. So you start with equal to, you do the word average, and you will see that function pop up in your list. So you can double click on that or just do average and open parentheses. And then remember, this is where you select your cells. So you can either type them in or use your mouse to select those cells, and then you just close your parentheses, and it will do the calculation for you. Because remember, the other way you calculate your mean, and again, this will be something, if you guys have not gone through chapter 3 text or handouts yet, remember, this is where you add all the numbers together and divide by how many total numbers you have. So that's the same thing what the average function does. So it's adding up all the numbers individually and then dividing by how many ever total numbers you have. And like I said, in my case, I went with 20 numbers. So that's what it's doing. It's taking the total of those 20 numbers and dividing it by 20. So that will be the same thing you will be doing for all of the rest of them. So, again, you can do equal to, we can use the median function. Um, does anybody know what the median measurement is, for an average? What does the median mean? Like the average, the mean is where, like I said, you add all the numbers and divide by how many total numbers you have. What does median mean in a measure for central tendency? Any idea?
Isn't the median the one that's like in the absolute middle? it's represented in the absolute middle of all of the data values.
Yes, very nice. Very good, Lola. And Riley, I just saw your answer also. You said it is the middle number when all the numbers are arranged from low to high. Exactly. So very nice. If you arrange all your data sets from smallest to largest, then whichever number falls in the very middle. Now, median is a calculation where you have to be careful, because think about it. If I have 20 numbers in my data set, that means two numbers will actually fall in the middle. So what happens in that case, you end up taking an average of those two middle numbers. Now, if you had odd numbers, let's say like you had 11 numbers in your data set, then yes, it becomes the centermost number. But if you have an even number of data sets, then you end up taking the average of the two middle numbers. But that's exactly what the median is. So again, you can do same thing, equal to, do the median, and then open parentheses, and then put those cell numbers in there where your data value is going to be, and that should help you calculate the median. For range, Lola, I have not found a built-in function, but for standard deviation, yes, if you will look at sheet 2 of the handout, the link that I sent you, you will see we use the STDEV function. And I think it's the same function in Excel also. But if you start typing, you might see something different. But I think it's similar to Excel. So same thing with mode, guys, obviously use the mode function. But again, can somebody tell me what the mode measurement is compared to your mean and median, what the mode is?
Isn't the mode the number that occurs the most out of all the, or the interval that occurs the most out of all the data points?
Yeah, very nice, Jacob. That's exactly right. So the mode is which number occurs the most often, as Jacob said. Very good. So again, your mode function will help you find that out. And this is interesting, because the reason you have so many different calculations for averages is one measurement cannot be used in all types of data sets, right? Because think about it this way, and in your handouts, you will see an example where we talk about this. I think it's like a small company that has 5 or 6 different employees, but the owner is making like a 6-figure salary, right? Like maybe $100,000, but the rest of the employees are making somewhere between $10,000 to $20,000. I think there's a manager who makes about $40,000. So in that case, what will happen is if you try to add all the salaries these people are making, because the owner is making a 6-figure salary, but then you have the employees making somewhere between 10 and 20,000, what happens is that $100,000 brings your average up, right? Because it's going to bring it more closer to that $100,000 than to the person making $10,000. So what happens in that case is, if we were to look at the mean as the calculation, then we would say, oh, everybody's making $50,000, $60,000. This is a very successful business plan, everything looks good. But if you think about this, most people are not even making $40,000. Most of those employees are, like I said, somewhere between 10 and 20, and I think the manager is the only one who makes somewhere near 40,000, but your average is coming out to be 50,000 because of that owner salary. So that means the mean is not going to be a good calculation in this situation. So in that case, you either want to go with the median, but again, if you go with the median, the manager is kind of going to fall in the middle, because he's going to be at that $40,000 salary. But then again, everybody is kind of at the bottom. So it may make more sense to use mode, because you would have multiple employees between that $10,000 to $20,000 range. So it really makes a big difference, because remember, guys, all of these calculations are called as an average. So your mean is an average, median is an average, mode is an average. So average is a very ambiguous term. And a lot of times if people just say the average is, whatever, you really need to go a little bit deeper and say, well, what calculation did they use? And actually there's one more calculation that we have for measure of central tendency, which is called mid-range. So think about the word, it's mid-range, sounds very similar to range, but the difference with mid-range is instead of subtracting the two numbers, you take the highest data value, add it with the lowest data value, and then you divide it by 2. And that's how you calculate the mid-range. So there's actually 4 different calculations. Unfortunately, your textbook does not emphasize much on mid-range, but there is one more calculation basically. Alrighty, so like I said, just use the different functions I have listed over here, and you should be able to see your numbers coming up. And I can see Lola. So Lola, can you tell me a little bit about what songs or what musician you went with?
Yeah, I did Ariana Grande, her song Santa Tell Me, and it was on it was on the spreadsheet 1, 2, 3, 4, 5 times. So I used in column C, weak position, I used like the position, those data values to and use the spreadsheet function to calculate the mean, median, mode, range, and standard deviation. There was no mode because of the like 5 billboard positions on like the chart. It was
because
all
you have
different numbers.
Small data set, right?
Yeah, it was a small data set, and also there was no repeating data values. So there wasn't a mode, I'm pretty sure.
Yeah, because if you don't have any repeating data values, then your mode is going to be unavailable, or basically we say no mode. Yeah, very nice.
Yeah.
Okay, and then you got a mean of 62.6 and a median of 64.5. All righty, range is 50 and standard deviation is 17.05. Okay, so I'll give you guys another couple minutes, and then I did want to talk about what exactly is a standard deviation. So like I said, take a couple minutes, finish putting in your information. So it looks like Riley, you are also done with your calculation. So can you tell me which song or artist you went with?
I went with Mariah Carey.
Okay, and then did you choose all the songs she had on the list, or you went with a particular song?
Yeah, I went with all of her songs.
You went with all of her songs. Okay, so looks like you got a mean of 32.714, median 26, and a mode also of 26. Okay, range 89 and a standard deviation of 21.67. Okay. All right, so we're waiting on, let's see, Crystal, Amaya, Dylan, Jacob, and Elijah, I believe.
I did all my calculations and just the copy I made. So it won't like show up. Is that okay?
It's not showing up.
No, I did it in the copy of the spreadsheet that I made.
Okay, so are you able to go back to the original link?
Yes.
Okay, so if you wouldn't mind just typing the answers you came up with in there, Dylan.
Okay.
Thank you. And I'm gonna share my screen. Hopefully you guys can see that sheet too, from the link I sent you, but you should be able to see all the different information your classmates are putting in there. Anyone who is having trouble with their data set or with calculations or anything like that? Okay, Amaya, so what song did you go with? Okay, you said Justin Bieber. So let me sort our list by artist. I think it's already sorted. Okay. So let's see. There he is. Okay, so Amaya, what you want to do is once you are down to that song, Mistletoe, you want to select all those numbers, in column 3, which is the week's position. You want to select all those numbers and then, copy it and do this at your end, make a copy of this Google Sheet, and then you can basically go to sheet 2 on your the copy that you make, and then use that as your data set. So kind of like how I have those 20 numbers that I selected at random, you will have, it looks like, what's that, 3 4 5 6 7 8 9 10, so it looks like 10 numbers there, and then use those to do your calculations, where you are using the average function for the mean, the median and the mode functions for those two calculations. And then you will see instructions on how to calculate the range and the standard deviation in there also. So give it a try and let me know if any of that is working for you or not. But copy those numbers, from the third column next to your song Mistletoe, and then go ahead, copy and paste them on page 2, and then go ahead and do your calculations from there. So Dylan, can you tell me which song or artist you went with?
I just chose All I Want for Christmas, and I didn't like pick a specific artist. I just went with all the song in general.
Okay, so you went with the song.
Yeah.
And that probably led you with multiple different artists, I might imagine.
Yes.
Okay, so this is not sorting the way I want to. Okay, let's see if I can find. And so how many data values did you have in your song? I mean, in your data set?
There's 20, I believe.
Okay, so you went with All I Want for Christmas. Okay, so this is actually coming from, it looks like two different artists in here. And Riley, didn't you use the same song?
No, I just did all of Mariah Carey's songs.
Oh, you went with the artist, not the song. Okay, got it. Because yeah, that would have been a nice comparison, but you can see there's a little bit of difference, or actually quite a bit of difference between yours and Dylan's data, even though there is some overlap with the songs in there. All righty, very nice. Crystal, what about you? What did you choose for your data?
I chose artist Boys to Men.
Boys to Men, okay.
Mhm.
And how many data items did you have in yours?
I think there was 7. Let me
7, okay.
go.
Boys to Men. Yeah, that's a small data set also. Looks like the song is Let It Snow.
I think it's the only song, yeah.
Yeah. So what's that? 7, I think, data items.
Yeah.
So you've got no mode in yours either. 58 for mean and median is 60, range 55 and 17.72. Okay. Jacob, what's going on with you? I'm not seeing any information from you.
So I chose Nat King Cole, the Christmas song. I'm just confused on which row is my data point. Like what would be my data points that I add up? Would it be L, M? What row?
Okay, hold on. Nat King Cole. Okay, so how many data items are we looking at?
8 should be.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. So again, copy those 8 numbers, bring it over to sheet 2. And then you are using, again, those functions that I have listed over here to do your different calculations. So, bring those 8 numbers to your sheet 2, copy paste it, and then use the built-in functions to do those. But remember, you're typing your results in the link that I sent you and not in your own copy, because if you do it on your own copy, then all of us cannot see your data values.
Right.
But you can do the calculation at your end and then just bring the numbers over once you're done calculating them. Delija, Amaya, are you guys able to move forward?
I'm just having like a little trouble like trying to like edit it and stuff, but it's because I broke my computer. So I'm trying to like, yeah. So it's just taking me a little longer.
Okay, so were you able to pick a song or an artist you were interested in?
I was gonna do Mistletoe by Justin Bieber too, but I can pick a different song if
Yeah, just for now, pick a different artist so that way, we can get to see a little bit more difference in our calculations.
okay.
So what happens here, guys, you will see not all our mean, median, and mode calculations are coming out to be the same, right? Because you do have that variation in your data set. So sometimes, depending on how consistent your data set is, those numbers can come out to be the same. But it has to be, and when we get into our discussion with normal distribution, you will see actually those are the types of data sets where your mean, median, and mode are going to be the exact same number. If you talk about, if you had to talk about the height of all American adults, all the adults living in the US, because that's actually a calculation which is normally distributed. So that's where, your mean, median, and mode end up being the same number. But as you can see in this data set, we are not really seeing a whole lot of overlap. Now, numbers can be closer together. So you can see in Lola's data set, your mean and median are just very close to each other at 62.6 and 64. For that matter, Crystal, your data is pretty close to each other because you've got 58 and 60. Riley, you're not that far apart either, but I mean, you still see a little bit of difference because you're almost at 33 with the mean, but 26 in the median. Same thing, Dylan, you're not too far apart. You're almost at 64, and then your median is 67. If you look at the calculation I have in there, you know, from 68 to 70. So you can see they're still pretty close to each other. Now, if your data set was too varied and like too spread out, then you would see a big difference between the mean and the median calculations. And those of you who have the mode, you can see a mode kind of does its own thing, though Riley looks like your median and your mode came out to be the same numbers, but then we have Dylan with, you know, 45 for the mode, because again, remember that's the number that's repeated most often. So a lot of times the mode may not be close to what you see in the mean and the median calculations, because remember the median is based on the position, right? As you guys were defining it before, that you set your data set in order from smallest to the largest numbers, and then you have to find the centermost value, which is your median. But mode, you know, because it is what number is repeated the most often, it can be anywhere in your data set. So it's not really dependent on the position. So it's really interesting how different these calculations come out to be. So that's your measure of central tendency. But when we talk about dispersion or variation, we're talking about how spread out your data is. Now look at Riley's range value. It's 89, which is telling me our data set is pretty spread out, because that means the difference between the largest number and the smallest number is 89, which means there's a big gap in there, right? It's more spread out. But then you have Lola, who had a range of 50, which is of course the smallest number that we're seeing right now in this little table over here. So that tells us that maybe Lola's data is not quite as spread out as Riley's is. But you know, a range again does not give you the entire picture. It's just a very small part of that calculation of how spread out your data is. So this is actually where we bring in this idea of standard deviation. If you guys have looked at, you know, any definitions or a concept behind what standard deviation is basically calculating an average. So it's actually still doing a calculation of an average, but this time it's calculating how far away from the mean is your data point. So it looks at each data point and it tries to see how far away from each of those points your you know, single data items are. So if you look at, and again guys, I am looking at page 2 of the link that I sent you. So you can see how in column J I kind of pasted my data set. So just using that, I'm gonna actually get rid of this empty shell over here. So just to show you, if these were my you know, data items that I was using to do my calculations, and I wanted to know how far away from the mean they are, all you have to do, and I'm just going to use the built-in functions to help me out, but all we have to do is take the difference between the data number itself. So I will do 83 minus our mean, which, you know, for me came out to be 68.368. So all you have to do to calculate how far your data value is from the mean is take that data value and subtract the mean from it. So 83 is about 14 points, you know, away, or 14.63 points away from, you know, my mean. And I can do this for all of these columns. So each of these numbers, I am basically taking the data value itself and I'm subtracting the mean from it. So what happens, guys, if the number, the data value you are looking at is larger than the mean, you get a positive answer. If your data value is less than the mean, you get a negative answer. So again, if the number is larger than the mean, you will get a positive answer. If it's less than the mean, you get a negative answer. And this calculation that I just did is what we call as deviation. Remember, the idea behind deviation is we want to know how far away from the mean your data item is, your data value is. Now, what happens in this case, if I wanted to find the average for these numbers, I would go ahead and add up my column. So that's the sum function. So I would go ahead and add up this column. But imagine what's going to happen when I try to add all of this up. Okay. Did you see what my total came out to be? My total came out to be 0. Now I cannot do 0 divided by any number because 0 divided by any number is 0. So that's actually the problem we have when we are trying to calculate, just the average of how far away our data items are from the mean. So what we end up doing is we do a little bit of a math kind of trickery to get away from this total of 0. So instead of adding up this column of our deviations, what we do is then I need to do this. Not what I was doing. Okay, there we go. So to get rid of, coming up with that total of 0, what you end up doing is you end up taking a square on your deviation column. So, all these numbers that we have, positives and negatives, we end up doing a square on that. And you will see when we do a square on these numbers, they all become positive. So you will see all of these negatives have now become positives, right? Because negative times negative becomes a positive. So just using basic algebra to help us out over here. Now, when I try to add this column of the squares, you will see since we are adding all positive numbers, obviously we are not going to get total of 0. You now end up getting a total of 55,020. So this is kind of where we are using algebra to help us out. And then if you actually look at your standard deviation calculation, and I think I've opened up your handout over here to kind of show you that. And this is really great, handouts. If you have not had a chance to look at them, I would. So, they talk about 2 different calculations. One is for the population standard deviation. Now, since you guys have been through chapter 1, you will recall that population means you're taking into consideration all of the items that would fall under that category. For us, our population would be this entire list of Christmas songs. But since we're not using the entire list, we're only using a part of it. You can actually use the sample standard deviation formula over here. And this is kind of what your formula looks like. So we've actually done part of this calculation already. We took our data value, we subtracted the mean from it, which gave us, those positive and negative answers. But then we went ahead and squared those numbers because just adding them by themselves was giving us a 0. So we took those subtraction values that we had, data item minus the mean. Then we squared the entire thing and then we added them together, which is what gave us this total of the 5520.421053. Now, because we are only looking at a sample, you will see this numerator is being divided by n minus 1. And we do that to make a little adjustment in our error of calculation. Since we're not using the entire population, we're just using a sample, we always end up dividing by n minus 1. So what I will do, just to show you, is take this total of 5520 and divide it by, let's see, we had 19 items. So I'm going to do 19 minus 1, which will be 18. So I'm going to divide that by 18. And this number that we just came up with is what we call as your variance. And you will see all of those terminologies and formulas in your textbook or even these handouts. So literally the only difference between your variance and standard deviation is the square root. You essentially calculate the variance, take a square root on that, and that gives you your standard deviation. So look at that. We use S square as the notation for variance. And when you end up taking a square root on that S square, it just becomes the letter S, which stands for standard deviation. So now that we have calculated our variance, we can go ahead and calculate our standard deviation, which will literally be the square root. And again, I'm just using built-in functions to help us out with that, of this 306.69 number. And you can see it comes out to be 17.512. Now, if you did this same calculation just using the standard deviation function, and I'll do that right over here. So the STDEV function I was telling you guys about, and I just use my original data values for that. I think I'm actually missing a number in there from my original data set because I had 20, but for some reason there's only 19 right now. And you will see, our calculation is a little bit different. This is actually because this is for population. Let me see if I can find the one for sample. This is population. I believe the dot S is the one that should be for the sample. No, still giving me the same number. Okay, let's see what happens if I divide this by 19. Nope. Okay, so there is a little bit of a difference in calculation. It shouldn't be that drastic, but you can see there's definitely 1 point difference. But again, guys, at the same time, I will tell you in statistics, you are not going to be working with exact calculations or numbers because your data set can keep changing. If I go from one sample to the other, my data set can change. And so a lot of times, if we were looking at real life data and using them to do calculations, not all your calculations, depending on the method, are going to come out to be the same. But I am still okay with this being a difference of 1 point, going from 17.5 to 18.5, just based on the difference in our calculations over here. But like I said, still at the end of the day, your standard deviation is telling you on an average how far apart is your data values from your mean. And you can see we are saying on an average, our data value is about 17.5 to 18.5 units away from the mean. But then look at some of the other information you guys had in here. And I see that, Jacob, you've got your numbers in there. So what song did you go with, Jacob, again? Remind me, or artist?
Give me a sec to pull it up. I think it was Nat King Cole.
Nat King Cole, that's right. So yeah, you can see with Riley and Jacob's numbers, they are, their standard deviation is in the 20s. So you've got 20.7 from Jacob and 21.6 from Riley, but then Crystal, looks like you had a 17.72 as your standard deviation. So even just looking at these numbers, and they're just in a couple points of each other, but this tells you Crystal's data set is a little bit more closer to the mean compared to what Jacob and Riley have. Dylan and Lola, you guys are also kind of in the middle. So the smaller the standard deviation, that means the closer you are to the mean. The larger the standard deviation, that means the farther away you are from your mean. And you can kind of see that with the range value also, right? Because you can see Riley had the, Lola, that's a good question, and I'll talk about that just in a minute. So Riley, you can see, had a pretty spread out data because she's got her range of 89, which tells you the data was spread pretty far out. So that kind of makes sense that Riley's standard deviation was a little bit larger. But then if you look at Lola's range, Lola had a range of 50, but compared to that, her standard deviation is still a little bit higher at 19 compared to what, let's say, Crystal had. You know, her range is 55, but her standard deviation was only 17.2. But that still kind of tells you, you know, they're still pretty close to the mean and not as spread out as what Riley's data is. So Lola wanted to know, how do you know when you have to use the sample or the population standard deviation? So Lola, basically, if we assume that the entire list of those songs that you're looking at, if that's your population, and if you were going to use all those 300 something data values, then you would use that as a population calculation. But since you are only looking at small parts of it, you know, based on one singer or one song, you are looking at a sample. However, guys, we can still make the argument that this list of Billboard Christmas songs is not covering all the Christmas songs, not all the chart numbers. So even if you were going to do all those 300 some calculations, we could still make the argument this is just a sample and not the entire population. So a lot of times you will see in your description when you guys go through homework and examples, they will tell you to use population or sample, because sometimes they will say this is your entire population. So that's when you will use the population calculation. Or they will say, you know, we just picked 1,000 people out of the population. So that means you're only looking at a sample. So in Lola, unless they specifically mention population, always make the assumption it's a sample. Because, you know, otherwise your population would have to be either the entire population of the US or entire population of the world. If they're talking in terms of car manufacturing, you know, they may not necessarily mean all the cars manufactured around the world, right? They could just be looking at a small data set. So for the most part, we assume that it's going to be a sample unless they specifically tell you this is the population. So guys, the activity, the assignment you guys will be working on this week, and I actually realized that I had made a mistake in my instructions that I put in there. So I'm actually going to fix it, but I just wanted to show you, you know, on Saturday night, the activity that you guys turn in, it's actually going to be based on something similar to what we just did in class today. So this was just to get you, you know, kind of practicing with those mean, median, mode, you know, standard deviation range calculations. But this one is just using the data set of the age of US presidents, you know, at the time of their inauguration. And I'll have you do some calculations. So this is kind of what your data set will look like. So, you know, we're going from George Washington to Joe Biden, you know, so that covers all our presidents. Now, some of them had multiple times that they got elected. So in that case, and Grover Cleveland is definitely one of those precedents where we're only using his age at the time of his first inauguration and not when he was inaugurated the second time. And so we're only using it for their first inauguration. So that's why you will see we don't have, repetitions in terms of the people who were presidents, but you will be kind of doing the same type of calculations that you did over here for your project. So hopefully you guys will get a chance to kind of practice. And, you know, this link is available to you guys if you wanted to play around a little, practice a little bit more, because I can see some of you did not enter your information. So obviously you are still working through those. So make sure you're comfortable with doing these calculations. If you want to do your calculations by hand, using the formulas in your textbook, obviously you're welcome to do that, but then I will need a description from you on how you did your calculations if you're not doing these built-in ones. So if you guys have any questions, you know, feel free to stick around after class and stay back to ask me a few questions. Don't forget to request your password. Your assignments for chapter 2 close at midnight tonight. if you're still finishing up chapter 2, go ahead and request your password. And if you want to go ahead and send me an email requesting the password for chapter 3 so that you have it ready, whenever you take the exam, go ahead and do that as well. So, because again, remember, over the weekends, I will not be available. So go ahead and do that before the weekend. So any questions that are coming to mind at this point, guys? No questions? Okay, if you don't have any questions, then I will see you guys next Monday, and shoot me an email if you need any additional help. All right, guys, have a wonderful day. Take care, and I will see you. Actually, I will not be seeing you on Monday. I'll be seeing you the following Monday, but I'll send you an email. Okay, bye everyone. Take care.
Quick question about the last assignment you showed. Will we be able to find